Hello and welcome to another video. In this video, I'm going to continue talking about the accessory organs in the digestive system. So my last video about the accessory organs was mainly about the liver. Now in this part, I'm mainly going to talk about the structures and walls of the bile pathway. I'm also going to talk about the topography and the structures of the pancreas, and also the topography and the structures of the spleen. So we start with the bile pathway first. So in the bile pathway, you have different structures responsible for different functions. You can have the liver here, and the gallbladder here, and the pancreas here, and you also have a perfectly drawn duodenum right here. So the bile pathway is this green tube right here. It all starts up here at the liver because the liver produces the bile, and if you're a little unsure about what bile does, it mainly aids the digestion of lipids. Now, I'm not going to go into too much detail into the physiology of bile because I really only want to focus on the anatomy for now. But the bile roughly contains around 97% water and around 1% different salts and some slight percent of bilirubin and fat. So that's what comes out from the liver. So the liver produces the bile and sends it through the ductus hepaticus dexter, the right hepatic duct, and the ductus hepaticus sinister, the left hepatic duct. And they come together and unite in the middle and forming ductus hepaticus communis, the common hepatic duct. And the common hepatic duct is about 5 centimeters long and goes out through the porta hepatis, which is protected by the hepatoduodenal ligament. Alright, so it continues down and becomes ductus choledoductus in Latin. I don't know if I pronounce it right, but in English it's the bile duct. But you can also call it the common bile duct because it is made up of the common hepatic duct and also the ductus cysticus, or the cystic duct. And as you can clearly see, the cystic duct leads into the gallbladder, the vesica biliaris. Now, I want to focus a little bit on the gallbladder because it has some important anatomical structures. So the gallbladder is here and is directed forward under the liver, and it forms a fossa called the fossa vesica biliaris. Now, to look at the gallbladder in a little more detail, let's go ahead and grab it and then pull it out. It will look like this. Now, the gallbladder's main function is actually just storing the bile produced by the liver and concentrating it before sending it away to the intestines. So it's divided into 3 parts. You have the rounded anterior part called the fundus vesica biliaris, and then you have the body of the gallbladder, the corpus vesica biliaris, and also the last part becoming the column vesica biliaris, which continues into the duct I mentioned earlier, the cystic duct, or the ductus cysticus. Now let's go ahead and open up the gallbladder to look at the walls of it. So let's zoom in. The walls of the bile ducts and the gallbladder are formed by 3 layers. You have the inner one is the tunica mucosa, highlighted for you in green. The tunica mucosa has these folds on it called the plica tunica mucosa. You'll find them along all 3 parts of the gallbladder, but another structure you'll find on the tunica mucosa in the region of column vesica biliaris and the ductus cysticus, and that is these extra folds called the plica spiralis. And the plica spiralis kind of surrounds the walls of the column vesica biliaris and the ductus cysticus. Alright, and so another structure you'll find on the mucus layer are these mucus glands, the glandula mucosa, which make sure that the inner surface stays lubricated. So that is the first layer. Next we have the muscular layer, the tunica muscularis. And what's interesting here is that usually the tunica muscularis has 2 different muscle layers, but on the bile pathway it only has one. It's one layer called the stratum circulare. Now keep that in mind that this goes to the rest of the bile ducts as well, not only the gallbladder. Alright, and then on the outer layer we call this one the tunica adventita or the tunica serosa. And so if you remember the differences between the tunica adventita and tunica serosa, tunica adventita is only going to be a connective tissue covering, while the tunica serosa is going to be a slippery surface of serous membrane formed by the peritoneum. So if you look at this picture right here, the only part covered in tunica adventita is right here in fossa vesicalis biliaris. But the rest of the gallbladder is covered by the peritoneum and therefore has the name tunica serosa. And also remember I said that these ducts here are protected and covered by the hepatoduodenal ligament. This ligament is a part of the peritoneum and therefore gives them a serous membrane as well called the tunica serosa. So you got the ductus hepaticus communis right here and ductus cysticus, which goes together and form the ductus coedoductus. And they're all covered by the ligamentum hepatoduodenale, which forms the tunica serosa. So if we go back to this picture again, now we know that the common hepatic duct and the cystic duct joins and forms the bile duct or the ductus coedoductus. So now I want to focus on this one a little bit. So the bile duct is here. It goes behind the superior part of the duodenum and the pancreas. So if we remove a part of the pancreas so they can see it better, you can see that the bile duct is this one right here. It's about 7 centimeters long, and if we kind of change the angle a little bit, look at it anteriorly, you will see the bile duct is here, and near the end of it, it connects with the pancreatic duct, which secretes the pancreatic enzymes with the bile, aiding the digestion. And these two join and form the ampulla hepatopancreatica, the hepatopancreatic ampulla. And then they open up into the descending part of the duodenum, forming the papilla duodeni major in the duodenum. So here, logically enough, you need something that makes sure the food you eat doesn't go into the bile duct as it secretes the bile. And it does that through this sphincter right here formed by the single layer of circular muscle fibers in the tunica muscularis. The sphincter it forms is called the sphincter ampulla hepatopancreatica. So if you remember the hepatopancreatic ampulla, it's easy to remember this name, the sphincter ampulla hepatopancreatica. Alright, so now we've gone through the anatomy of the liver, the gallbladder, and the duodenum. Now let's look at the anatomy of the pancreas a little bit. The pancreas looks like this and has two functions in the body. It has what we call the endocrine function and the exocrine function. The exocrine part of the pancreas secretes the pancreatic juice, or the succus pancreaticus in Latin, which contains different digestive enzymes, and also bicarbonate, which neutralizes the acidity of the stuff coming from the stomach. Alright, and the endocrine part of the pancreas is mainly sugar metabolism through these two hormones here called the insulin and glucagon. Insulin reduces the sugar while glucagon increases the sugar in the blood. So the pancreas has really important functions in the body. So the pancreas weighs around 60 to 100 grams, and it's about 14 to 18 centimeters long and 2 to 3 centimeters wide. And if you look at the abdominal cavity anteriorly, the pancreas is here. And if you remove everything, you'll see that the pancreas lies inside the epigastric region, also the left hypochondriac region. And so the pancreas has three parts. It has a caput pancreaticus, which lies in front of the second lumbar vertebrae. And also has a corpus pancreaticus, which crosses the vertebral column. We also have a cauda pancreatica. The cauda hepatica reaches the visceral surface of the spleen at the level of the first lumbar vertebrae. Alright, now if we go back to this picture again, this is the posterior view of the pancreas after removing some parts of it. Just a quick review of the bile pathway again. Here is the pancreatic duct, which joins the bile duct or the ductus coedoductus and forms the hepatopancreatic ampulla and enters the duodenum as papilla duodeni major. So the pancreas has this main duct right here, but it also has an accessory duct called the ductus pancreaticus accessorius, or the accessory pancreatic duct, which opens up into the papilla duodeni minor above the papilla duodeni major. And the accessory pancreatic duct secretes the same juice as the ductus pancreaticus, the pancreatic juice. And remember, this one contains the digestive enzymes, also contains bicarbonate for neutralizing the food that comes from the stomach. And so that was all I had for the accessory organs in the digestive system. But I wanted to quickly add the spleen as well, as I mentioned earlier, because even though it's not a part of the digestive system, but a part of the lymphatic system, the spleen is connected to different parts of the abdominal organs through ligaments. and we call it an intraperitoneal organ. I'll talk more about this when I talk about the peritoneum. So as I mentioned earlier, it belongs to the lymphatic system, and its main role is to destroy old red blood cells. And so the spleen weighs around 140 to 200 grams, and it's about 12 to 14 centimeters long and 8 to 10 centimeters wide, and 3 to 4 centimeters thick. So it's not that big compared to other organs, but it serves a really important function in the body, and it contains a lot of blood. So if something would happen in the spleen, you'll get severe internal bleeding. And also what's interesting with the spleen is that, have you ever run so much that you've reached the point of exhaustness that you feel kind of a pressure on the left side of your ribs? You know, when you run, the heart's gonna beat a lot and it's gonna pump the blood and increase the blood pressure, and the spleen contains a lot of blood. So, and that pain you feel on the left side of your ribs when you run, that's your ribs receiving that high pressure blood. Alright, so if we look at the abdominal cavity anteriorly and at the perfectly drawn diaphragm right here, you will see the spleen on your left side, right under the diaphragm. So it lies on the left hypochondriac region, and the spleen has two surfaces. It has a diaphragmatic surface, which faces the diaphragm right here, and also has a visceral surface close to the stomach, pancreas, and even the left kidney and the transverse column. But there's an important structure you'll find here called the helium sphenicum, which is the entrance and exit of vessels and nerves. So there's not a lot to talk about the spleen in general, but the spleen is protected. It's covered by two types of coats. The first being capsula fibrosa. That's a fibrous layer that's around the spleen. And then on the capsula fibrosa, around it, there's a tunica serosa, which is formed by the different peritoneal ligaments. So if you add the diaphragm again, the first peritoneal ligament you will see is the ligamentum gastrosplenicum. That's the ligament that connects the stomach to the spleen. And it's also connected to the diaphragm through ligamentum phrenicus-splenicum. Now it's kind of a hard name, but remember, phrenicum is everything related to the diaphragm. That's why it gets the name ligamentum phrenicus-splenicum. But it's also indirectly supported by one more thing. So if you add the large intestine right here, this is large intestine, there's a ligament attached to this flexor right here, the flexura colli-sinistra, that goes to the diaphragm. This one's called the ligamentum phrenicus-collicum, which the spleen rests on. So that was a video about the anatomy of the accessory organs in the spleen, and I hope that was helpful.